Good morning to all. I'm Sumitra, Associate Professor working in Triple Department of RMD Engineering College, and this semester I'm handling Renewable Energy System for 7th semester Triple students. And now in this video, I'm going to explain how the fuel cells are working in an effective manner to produce electrical energy. Now, before going into the concept about how the energy is produced using the fuel cell, we need to know what is a fuel cell first of all. So, your fuel cell is a device which is going to convert the chemical energy of a fuel into a electrical energy. So how this is happening means by means of some chemical reaction occurring in between the two electrodes of an um, fuel cell. Okay, the fuel cell basically consists of two electrodes, namely the um, cathode and anode. And apart from the two electrodes, we have an electrolyte also. So actually, the electrolyte is the responsible for the transference of the charged particles and the electrons from the cathode to the anode. And then, apart from the electrodes, electrolyte, we also need a catalyst, which is used to speed up the chemical reaction. So, with the help of a single fuel, we can able to generate a tiny amount of DC electricity. And then fuel cells, if you want to go for larger magnitude, we need to go for stacking of the fuel cells, or we can say a still or the stack, whatever may be the thing. The generation of electricity, that is the operating principle, is going to be the same. And now, why we need to specifically go for fuel cell nowadays? We have so many forms of energy, but regarding this fuel cell, it will provide a pollution free environment, and also the pure hydrogen is mainly used, that is commonly used fuel in all the fuel cell. And also the only byproducts from this process is nothing but the water and the heat, so it doesn't cause any harmful to the surrounding atmosphere. In that way, we can say it will provide a pollution free environment, right? And it is having a capacity to work of both a combustion engine and a battery with more efficiency and longer lifespan. Mm. And the longer lifespan is assured because it doesn't have any moving parts, so therefore no wear and tear is there. And the efficiency of the cell can also be improved if the fuel cell incorporates the thermal cogeneration system, which is nothing but harnessing the thermal output to run the turbines, right? So by means of the utilizing the thermal cogeneration capacity, we can go with the generation of additional electricity. So now, basic working of a fuel cell can be explained with two sentences. That is more than enough because we have the two charged electrodes. One is the cathode and the anode, and the anode at the anode only the fuel is getting oxidized with the catalyst. Then the hydrogen will be getting decomposed into the H plus ion and the free electrons. The H plus ions is having a uh, capability to pass through the semi-permeable membrane, that is through the electrolyte, and it reach the cathode, whereas the free electrons is not supposed to move through the semi-permeable membrane. So the only path available for the free electrons to move is that through the load. So while the electrons are getting towards the load, and then it moves towards the cathode after passing through the load. So this is how an electricity can be generated, or you can say an EMF can be generated in case of a fuel cell. Again, once the electrons, after reaching the cathode, it reunites with the hydrogen molecules there, and then it again forms the production of an water and carbon dioxide. Now, this is the block which will explain the operation working, what I said earlier. So, in the anode, the oxidation will be taking place. That is, the hydrogen, which is the most commonly used fuel, is getting passed through the anode. In the anode, the hydrogen is getting decomposed into H plus ions and E minus electron. That is, electron free electrons, and the H plus ions will have a tendency to flow over this, that is pass through this electrolyte, which is a semi-permeable membrane, and then it reaches the cathode, whereas the free electrons finds its path through the external load circuit, and then after passing through the load, that is after generating an EMF, it is moving, that is it is reaching the cathode, where it occurs again combines with that of the hydrogen molecules to come out with the water. This is how the basic working of a fuel cell can occur. And then this is the generalized chemical reaction that occurs at the anode and the cathode. So in the anode side, and as I mentioned earlier, an oxidation reaction will be occurring, which results in the decomposition of hydrogen as H plus molecules and electrons. At the cathode, a reduction reaction will be occurring, where these electrons, free electrons, again combine with the H plus molecules in the presence of oxygen to get the water molecule. And then the net reaction in a now, fuel cell is nothing but the redox reaction, so which is given by the expression 2H2 plus O2 is equal to 2H2O. And now there comes the next topic as the types of the fuel cell. Here, the types of the fuel cell are basically done based on the nature of the electrolyte used for each and every. So, based on the nature of the electrolyte, we have six different types of fuel cell like alkaline fuel cell, phosphoric acid fuel cell, solid proton exchange membrane fuel cell, and molten carbonate fuel cell, solid oxide fuel cell, and regenerative fuel cell. So in all the types of fuel cell, the working is going to be the same, whereas the electrolyte which has been used in each and every type is going to get deferred. Okay. Now coming to the first cell, which is called alkaline fuel cell. This is one of the oldest design of all the fuel cells, right? And it is very susceptible to the contamination. So in order to overcome this, we need to go for a pure hydrogen and oxygen, which makes this fuel cell to be somewhat costlier or expensive. So this type of fuel cell is that is very rarely used in market. That is, it is uncommercialized, unlikely to be commercialized. Okay. Um, the electrolyte used in case of this alkaline fuel cell is your aqueous potassium hydroxide, and it is said to have an operating temperature of about uh, that is 80 to 90 degree Celsius. Okay, and here the electrodes are made up of porous graphite, and the electrolyte that is electrodes are made up of porous graphite, and the electrolyte is nothing but a semi-permeable one, which is made of Teflon coated carbon material, and the working is at the anode, hydrogen is oxidized according to the reaction, which is given as 2H2 plus. I told you the electrolyte is nothing but potassium hydroxide. 4OH gives 4H2O plus 4E minus. On the cathode, at the cathode, this oxygen is combining with the free electrons to come again with the hydroxide ions. The net reaction consumes. It clearly shows that the net reaction consumes only one oxygen atom and two hydrogen atoms in the production of each water molecule. And this is the diagram which shows you the alkaline fuel cell used for the generation of electricity. So here the hydrogen molecule will be entering, and here we have an electrolyte which is nothing but aqueous hydroxide, that is potassium hydroxide, or it may be any hydroxide. So basically speaking, the electrolyte must be an aqueous solution. So the hydrogen molecule from this H plus ion from this hydrogen molecule is getting passed towards the membrane, and it reaches the cathode. And in the cathode, the electrons, after finding its path through the load circuit, will be entering. Again, it recombines with their thing to come out with the water molecule. And coming to the applications, these are mostly used because of their efficiency. And then the first alkaline cell was used by NASA, and the alkaline cell fuel is commercially incubated to a 22-seater hydrogen ship, which has been shown in this diagram. And then coming to the next type called phosphoric acid fuel cell, which is abbreviated as PAFC. And this is having a potential for use in small stationary power generation system, and it is operating at a temperature higher than the previous one, where its operating range is about 150 to 210 degrees Celsius. And here the electrons are made up of porous carbon containing the platinum, and the electrolyte is nothing but liquid phosphoric acid in Teflon bonded silicon carbide. So regarding the working at the anode, the reaction which is taking place is the same hydrogen is split up into the H plus ions and 4e minus electrons. At the cathode, the same 4e minus and H plus combined with that of oxygen to come out with the water. So overall reaction is 2H2 plus O2 gives 2H2O. So in all the fuels in operation, the only byproduct is a water plus some heat, right? So this type of phosphoric acid fuel cells are carbon dioxide tolerant, and even it can tolerate of carbon monoxide concentration of about 1.5 percentage. So because of this nature, this choice of fuel will have a broadened application, which seems to have an efficiency of about 70 percentage. And this is the diagram showing you the phosphoric acid fuel cell. Same thing, when hydrogen molecule enters, it is getting splitted to H plus and E minus. E minus find its path through the load, and H plus will reach the cathode. At the cathode, the same E minus and this H plus and O2 will combine together to form the water. And the applications of this, as I mentioned earlier, it is used for stationary power generators with a capacity of about 100 kilowatt to 400 kilowatt. And India's DRDO is developing this kind of fuel cell for air independent propulsion, and it also finds some applications in Navy sector also. And coming to the next type called the solid proton exchange membrane fuel cell, it is having the high power density when compared to the all types of fuel cell, and it is having a lower operating temperature. It is having a lower operating temperature And here the catalyst is used as ink or carbon, and the electrodes are sprayed or painted onto the solid electrolyte, and the carbon paper is hot pressed on either side to protect the inside of the cell, and it is going to act as an electrode. Okay. Mm, Now, coming to the working, the membrane, semi-permeable membrane of the electrolyte should having a capacity to conduct the hydrogen ions, but not the electrons, right? So the membrane must not allow either the gas to pass through the other side. So, if that happens, it will result in a phenomenon or a problem called the gas crossover. So the membrane must be resistant to the reducing environment also. So splitting up of hydrogen molecule is relatively easy by using uh, platinum as a catalyst. Okay, the splitting the oxygen molecule is more difficult, and this causes significant electric losses also. And this is the diagram which shows you the solid proton exchange membrane cell. And the applications is due to the lightweight, they can be suited for transportation applications like buses. It can be used as a compressed hydrogen for fuel, which have an ability to operate up to 40 percentage of efficiency. Okay, the next class I'll be explaining you the rest of the types of fuel cell along with the working. Thank you all.